okay, Snake?
Yeah. Nothing new to report.
I need help. Philanthropy received intel that a disguised oil tanker, register name USS Discovery, containing the new Metal Gear prototype, is motoring west. At noon, the Discovery is 10 nautical miles due west of our pursuit ship. The Discovery is sailing west at 17 knots, and our pursuit ship is sailing north at 19 knots. How fast in knots is the distance between the ships changing at 6 p.m.?
Hey, this isn't first grade math class.
You'll find the answer.
Thanks. We're all counting on you.
How will we find this ship?
I know just the guy to call. A calculus god, a differentiating diviner. He might just help with this. He goes by Agent Q. And ignoring his bad microphone, he's a damn good man.
He's our only hope.
Snake, this is Agent Q. An area of solve this problem. You need to take a formula describing the relation of the two ships' displacements to their relative distance, and then take the derivative of that formula. You need a answer. Philanthropy doesn't have the brain power to unscrew a light bulb.
Thankfully, I actually read that chapter in my textbook and dedicated time to develop a fundamental understanding, not just glossing over the pages. Let's check my work. I've drawn a diagram depicting the two boats, Discovery and the pursuit ship. Initially, they are 10 nautical miles apart. So I've made the pursuit ship the origin of the triangle. We are solving not just for C, which represents the distance of the two ships, but the rate of change of C at 1800 Eastern Standard Time, or 2200 Zulu.
You sure know a lot about related rates.
Pythagoras taught us that a squared plus b squared equals c squared, so we will use that as the basis of our formula. Differentiating with respect to time and simplifying yields c times the derivative of c with respect to time equals a times the derivative of a with respect to time plus b times the derivative of b with respect to time. Now we will solve for the distance. A equals the initial distance from the origin, 10 nautical miles, plus velocity, multiplied by time elapsed, yielding a displacement of 112 nautical miles for the Discovery. We do the same for B, representing the pursuit ship, and get 114. Now, since we have A and B from the Pythagorean formula, applying it yields 159.824 nautical miles. This gives us the distance, but not the rate of change of the distance after 6 hours. We solve this by plugging in our known values into the formula from the first step.
Then the rate of change is within our grasp.
We calculated the lengths A, B, and C, and we already know the speed of the two ships represented by the derivatives of A and B with respect to time. This gives us the formula 159.8124 times the derivative of C with respect to time equals 112 times 17 plus 114 times 19. If we multiply and add, we get 4,070. Dividing both sides by 159.8124 gives us our final answer. The rate of change of C with respect to time at 6 hours elapsed is 25.4674 knots.
You've done it. That's it. That's the rate of change of the distance between our two ships at 1800.
Good work, Snake. Thanks to you and Secret Foxhound drone resources, we successfully located the USS Discovery and are going for an infill no later than 200 Zulu. Since we found that the Discovery was traveling away from us at 25.5 knots at 2200 Zulu, we were able to project what window of time we have for a covert action to secure Metal Gear. We couldn't have done it without your superior knowledge of high school calculus.